Okay, so if you remember last time we talked about quantifiers and the negation of quantifiers. So let me just review a little bit so that we can start our lesson today. I will probably, hopefully, finish the lesson today, and then there are some geometry problems left. I don't know, have you thought about them or not? I will solve them, and then we are finished with this. And now we can decide about the exam when it should be, okay? So if you remember, we talked about quantifiers, the universal quantifier and the existential quantifier. So, and then we have uniqueness quantifier and this non-existential quantifier. But we told that the non-existential quantifier and the other one, the uniqueness, can be written in terms of those other two. Okay, so that's why we don't actually care that much about them. So, so this is a red for all x property px. So that's a predicate, which is not a statement, but it is a declarative sentence. But if you replace the variable x from the universe of discourse, then it turns out to be a statement. But if I put this quantifier here, even though this is still a predicate, the whole expression becomes a statement. Yes, that was the role of this quantifier. So, and then we studied about the negation of this. So do you recall what was the negation of this?
Every x not b.
No, the same scenario. Yeah, you should.
Didn't you change the operator and then move in the negation?
Can you repeat it again?
Well, is that maybe I'm confusing the current symbol? Can you,
This means for all.
Okay, for all. So then there exists a not p.
There exists an x not p. Yes, that was the negation of this universal quantifier. And then do you recall what was the negation of existential quantifier? Someone else? Yes.
For all x not p.
For all x not p. Yes. These were the things will be studied. So this is called the bound variable, if you remember. If you have extra variables in the problem which are not in front of a quantifier, they are called free variables. Yes. And then we also talked about bounded set quantifiers. Sometimes we want to talk about a portion of the universe of discourse, a subset of the universe of discourse. So, for example, assume that A is a subset of the universe of discourse, and then we can also talk about these type of quantifiers. They are called bounded set quantifiers. The variables are bounded to be in this particular subset of the universe of discourse. Yes. So then, if I have this one, but for this one, if you remember, we talked about a proof. But at the end of the day, it becomes exactly the same thing. So you don't do. So you just turn this universal quantifier to existential quantifier, but you don't touch this part, and then you negate this one. If you remember, we talked about why this is going to be true based on what we had before. Yes, do you remember what was the idea? Because any bound set quantifier can be written in a form which is not bounded. Yes. So do you remember what was that? So, for example, instead, if I don't want to use the bounded set quantifier here, this is equivalent to saying what? Do you remember? So I don't want to put A here. Yes.
For all x.
For all x.
X belongs to A, then p.
Then px. So this is exactly equivalent to this one. And actually, we showed that this is true, and then we started talking. This is the equivalent statement of that, and then we use this and this idea to be able to show this is also the case. So if you want to have the negation of a bounded set quantifier, universal quantifier turns into an existential quantifier. But this, you don't touch it, but you negate this part. Yes, and then the same story for existential bounded set quantifier. So if you have this, then this is also equivalent to saying that for all x in A, not P. Yes, so this is more or less what we learned before. And then I gave you an example. So if I have two quantifiers, one after the other, I want to talk about that part a little bit more today. But in principle, if you want to negate something like this, forget about what does it mean in principle, but let me just write this. Assume that you have a predicate which depends on two variables, and then you have two existential quantifiers, one after the other, and then you want to negate the whole statement. Yes? So you need to think in this way. You can take this one to be a Q of X, yes? And then you can imagine that using this rule, you can write it that this is equivalent to change this one to universal quantifier and negate your QX. Yes? But this is your QX. So if I ask you what is the negation of QX? What is the negation of QX? What's the answer? The negation of this quantifier, of this statement, becomes for all y and then not pxy. And then if I put this back here, so this becomes equivalent that for all x, for all y, not pxy. Yes? Yeah. And then it doesn't matter how many of these quantifiers you have one after the other. You can just follow exactly the same rule. So you can just, as a mnemonic, you can have it in mind that whenever I have existential quantifier, when I want to negate it, it turns into a universal one. It doesn't matter. The order is not important here for negating. And then you just follow this rule. And then at the end, you need to remember that you have to negate your predicate in front. Yes? And if you remember, before finishing the lesson, I give you the very exact, precise definition of a limit. We never use that definition. It is more advanced level. So I told you that what does it mean when we say the limit of f of x is equal to L when x goes to A? It's a little bit complicated. So this becomes for all epsilon greater. So let me write epsilon in this way. The reason is that this epsilon is again this letter. So to prevent confusion, we have also in LaTeX, we write epsilon for this, and then we have var epsilon to differentiate somehow. This becomes something like this. Okay, so both of them are epsilon actually, but because I am using epsilon here for this symbol for this belonging to, let me change my symbol to this epsilon, even though I wrote it in different way last time. So for all epsilon greater than 0, there exists a delta greater than 0, such that for all x, if x belongs to the domain of the function and 0 is less than absolute value of x minus a is less than delta, this a that you see is this number here, then the absolute value of f of x minus L is less than that epsilon. So this is the precise definition of a limit. You see, it's a little bit complicated. I don't want to go through it because I just want to talk formally about how to negate that. So then I want you to write for me this statement. What does it mean when we say the limit of f of x goes to a is not equal to number L? So it means that I want to negate this one. So my point is to write the negation of this a little bit complicated statement. Yes? So, and then you see that we have a lot of quantifiers involved, two existential quantifier, and then today I want to talk about you are not allowed to interchange these two. The meaning becomes quite different. I will talk about this. You can interchange universal quantifiers together. You can interchange existential quantifiers, but you're not allowed in general to interchange the existential quantifier with the universal quantifier. I will talk about that today, okay? So keeping the order in that way is actually essential. Okay, but forget about these things. everything you should be, formally you should be able to write the negation of that. But before that, let me make sure that you know these things. Let us review. So we know the negation of conjunction, yes? The negation of conjunction is negation of the first one. These are the De Morgan laws, yes? Disjunction with negation of the second. And then we also know that the negation of disjunction is conjunction, yes? Negation of the first one, conjunction with negation of Q. And then do you remember, that's also important to remember, what is the negation of a conditional? Yes?
Q and not P.
No. Yes?
Was it P or not Q?
No. Yes?
Not Q, then P.
No? So, yes?
Not Q and P. Oh, I said it already.
No, that's P and not Q. Yes? The reason that this is correct, I don't know, I always remember this. P, if P then Q is equivalent to not P or Q. This is a very important theorem. That's a fundamental theorem. So you need to prove it through the table, okay? So, and then if I want to negate this, it is equivalent to negate this, but then I can use the De Morgan law to negate negation of P is P. This will turn into and this will be negation, yes? So remember, this is a very important fact. Okay, so these are, of course, if you want, you can talk about this one as well. So let us practice. What is the negation of biconditional? So for this one, I don't remember, but I can calculate it. So do you remember there is an important, you don't really need to be, you don't need to use your memory. What is the meaning P if and only Q? P if and only if Q. So what is the meaning? This you need to understand. If someone asks you, okay, you are doing mathematics and specialization, what's the meaning of P if and only if Q? What does it mean?
P and Q.
No. You are not in a good mood today.
No,
Yes?
it was a long time ago.
No. P if and only if Q, what does it mean? It means if P happens, Q happens, and if Q happens, P happens, yes? Something like this. So it means P, if P then Q, and if Q then P. That is the meaning of P if and only if Q. You don't need to remember something. That's just the most natural thing. And if you want to negate it, I need to negate this one. So what is the negation of this one? This is on the board. Or, because this turns to or, and then negation of this one becomes Q and not P. Okay? But even you don't need to know the formulas. This is logic. Everything in mathematics we have done so far is based on our logic. Yeah? So when you say P if and only if, it means that either they are both true or they are both false. This is the meaning P if and only if. Yes? Is that understandable? Okay, now you want to negate this. It means that I found the circumstances in which P is true but Q is not, or I found the circumstance that Q is true and P is not. So when you say that P and Q are simultaneously true or false, this is the meaning of being P if and only if Q. Now you want to negate this statement. So it means that it is possible to have P but not Q, or it is possible to have Q but not P. More or less, this is the intuitive idea. So you really don't need to remember, even though I didn't remember the formula, but it is possible. Now let us go back to this problem. Let us do that, okay?
Do you know what the negate sign is called in LaTeX?
I think no, unfortunately, it is. I think it is neg. You can check that.
Okay.
Yeah. I'm not sure, but in principle it should be, because not. If you put not, then you put equality and you put not, it will put a bar on it.
Yeah, it was neg. Thank you.
So, yeah. Okay, so now let us write the answer to this. I want to write something for this. You see that this is the negation of this statement. This statement by definition is equivalent to this one. So if I want to negate this, I should negate this compound statement. Okay, but that is easy. First of all, do you see that this is a bounded set quantifier?
Yes.
Yes. Here, of course, I have to be careful. The universe of this course is the set of real numbers. I am talking about the limit of functions defined on the set of real numbers. But do you see that this is a bounded set quantifier? Yes. Why? Because when you say epsilon is greater than 0, it means that you are limiting the range of epsilon. So in another way of writing this, for example, is epsilon belongs to the set of positive real numbers. Yes? So epsilon greater than 0 is another symbol that we use for this. Epsilon belongs to the set of positive real numbers. Okay? For simplicity, people write this. And you saw that when I want to negate a bounded set quantifier, this part is not affected. Okay? Is that clear? So it means that this part is not affected, but this means that I am not allowed to touch this part. But I have to change the universal quantifier into existential quantifier, yes? So then this becomes, there exists epsilon greater, so I used to write epsilon in this way, but epsilon greater than 0. Okay, can you tell me what would be next? So again, existential bounded quantifier becomes universal, the same bounded variable, yes? So this becomes, there exists, for all delta greater than 0. Again, I have existential quantifier, so I can say that, that's universal, it becomes existential. Okay, this part I want you to write. So these three are these three clear? Yes. Here you see this will play the role of your P, this will play the role of your Q, and that is a conditional. But P itself consists of two parts, yes, which are connected with and together. So what should I write here? According to this formula that we had, I should keep the first component as it is. I will change the conditional to conjunction, and I will negate the second one. Yes?
So what's the, I think you displayed it there, but the operator predecessor, is that if then is more important than and?
These questions are very vague to me. I don't understand what is the meaning of being more important.
Like we have the rule BODMAS, that multiplication goes before addition.
Okay, priority.
Priority, yes. Because here it's
no, if you really want to, I have to. Yes, so that is a very good question. In principle, I was a little bit careless. Might be it's better to put this around that. Yes. Yeah. So that's a good question. I didn't care about these priority ones, but you are right. I have to put a pair of brackets around that. Because might be people read this in this way, this one and that one. I don't know exactly, is there some kind of rule for that?
I read it that way.
Pardon?
I read it in the other way.
Yeah, it might happen because you're right. You can take this one statement and this another statement and then conjunction with this statement and with this conditional statement. Now, but that is what I do. Okay, so I need to keep P the same, so it becomes X belongs to DF and 0 is less than X minus 8 is less than F delta, and then I need to change this to and. So in principle, if you want, you can still keep the pair of brackets and then negate Q. Okay, so if I want to negate Q, what should I do? If I want to negate Q, what should I write? I would say that this is not the case that f of x minus L is smaller than epsilon. So it means that this is not smaller than epsilon. That's the meaning, yes? But nobody writes like this in mathematics. When we say it's not smaller than this one, it means greater than or equal. Yes? So this is why I would write f of absolute value of f of x minus L is greater than or equal to epsilon. So if I want to remove, now I can safely remove the pair of brackets because now all of them are conjunction. Why I can remove the brackets? Yes?
I don't remember it now.
It's associative. So conjunction is associative. So it doesn't matter if you group these two together or if you group these two together. And it doesn't matter, so why we should bother to put the pair of brackets in the first place. So I would write it in this form. So there exists an epsilon greater than 0 for all delta greater than 0. There exists an x such that x belongs to the domain of f and 0 is less than x minus a. Absolute value of x minus a is smaller than delta, and absolute value of f of x minus L is greater than or equal to epsilon. Agree? So this is the negation. Of course, if this is more or less the same idea, it means that I can make the values of x closer and closer to L, but there is one condition. The condition is that I make x minus a, the difference between x and a, sufficiently small. Okay, so that is the same idea, but when you write it in a very precise way, it becomes a little bit horrible, but that's the same idea. So epsilon is a number. It tells you that you can make this difference between f of x and L, the values of the function and the limit, as small as you want, but under one condition. And the condition is that makes x close enough to a. So if you make x close enough, when the distance between x and a is less than delta, then it will imply that the distance between f of x and L is smaller than any positive number epsilon, no matter how big epsilon is, okay? But don't concentrate on this part. That's not my goal. Okay, and that's also, so let me ask you one question. Why do you think people write this? 0 is less than absolute value of x minus a. Because might be that's also a good question that because absolute value is positive, why we emphasize it. Because this means that absolute value of x minus 1a is greater than 0. Do we really need to emphasize here? Yes?
It emphasizes that x minus a is not 0.
Exactly. Thank you very much. So it emphasizes, this is in principle, people could write it in this way. Yes? But I don't know, because of beauty or harmony between these two, people write it like that. That is customary. But that is, when I say absolute value of x, it is not always greater than 0. It is greater than 0 or sometimes equal to 0. So this is a fancy way of saying it is not equal to 0. No, it's just something in passing. Okay, is that understandable? Now let me talk a little bit about the meaning when the quantity. This is also something might be confusing sometimes. I will take this example exactly from this book. So let me write the name of the book because I'm just stealing the example exactly from this book. So the book is called Set Theory, a first course. Cambridge Press and by Daniel W. Connick-Hunt. Okay, so I'm just using this example that this mathematician has actually written in his book. So, example. Let the universe of discourse be a group of people. And let L, X, and Y is a predicate, yes? That X likes Y. This is a predicate. I cannot say that this is a statement because I don't know if that is true or false, depending then the choices for X and Y. I have to make the choices for X and Y so that I can say that this is a true statement or a false statement. But this is a declarative sentence with those properties. So it's a predicate in two variables, yes? And I am allowed to say X likes Y because I have said that the universe of discourse is a group of people, and liking each other is very natural in the group of people, okay? So for example, I cannot say that the universe of discourse is the set of real numbers because then I need to define what does it mean, square root of 2 likes the square root of 3, yes? It's meaningless, okay? Now, we want to talk about these quantifiers. We want to read these in proper English. So there exists X, there exists Y, L, X, Y. Okay, so I will write them. You can also think yourself. This is a very nice example. So there exists a Y, there exists an X, such that L, X, Y. So number 3, for all X, for all Y, L, X, Y. Number 4, for all Y, for all X, L, X, Y. Number 5, for all X, there exists a Y, L, X, Y. For all, number 6, there exists a Y for all X, L, X, Y. So we want to read these sentences more or less in English, in colloquial English. We want to understand how to read these mixture of quantifiers. And this is a very good example to give you the feeling. Does this sentence means the same thing? Does this sentence means the same thing? Does this sentence means the same thing? Okay, by the way, if from English point of view, if you want to say the same sentence, but if you are supposed to start with Y, how do you read it? So this sentence says that X likes Y. Assume that you want to transfer the same idea, but you want to start with Y. Yes?
Y is liked by X.
Yes, so that's also equivalent. So you can say Y is liked by X. They are, from English point of view, they are equivalent. I want to use them somehow. So what do you think this means? Can you write it? Can you say it in a very simple English sentence? Yes, Alex?
There exists at least one person who likes somebody else. Or who likes somebody at all. It could be himself as well.
So you need to think first. It's confusing.
Who likes somebody.
So a very, very simple phrase. So let us try to understand that.
Someone likes somebody.
I think it's correct somehow. So let us write. So when you say exists an X, there exists a Y, L of X and Y. This means that there is a person X such that, let me write again in mathematics. Yes? Do you agree that this sentence means there is a person X such that there exists a Y, L, X, Y? Yes? Now, let me translate this one as well. So how do you translate this one? So there is a person X such that X, so there exists a Y such that X likes Y. Yes, that's the meaning. So it means that such that there is a person Y, there is a person, no, let me write it in this. There is a person X such that likes a person Y. Something like this. But of course, this is more or less a mathematical way of expressing things. But as Alex said, this can be summarized into someone likes someone. Yes? So you see, there is a person X such that this happens. But what is the meaning of this? This means there is a person Y, LXY. So there is a person Y so that X likes Y. Yes? So there is a person X such that likes a person Y. So this can be summarized to say someone likes someone. Yes? So this sentence in mathematics means someone likes someone. Is that understandable? Yes or no? Okay, now can you tell the translation of this one?
There is someone who is liked by someone.
Yeah, so it means someone is liked by someone. Yes? So number two, so that was number one. So number two means someone is liked by someone. Now think a little bit. What do you think? Do you think this is a new information? This contains a new more information than this one or the other way around? Or they are the same? Someone likes someone. Someone is liked by someone. Are they the same or not? You shouldn't doubt about your knowledge in English, yes. So when you say someone likes someone, it means that you can find a person here, another person here, so that this person likes that person. Yes? But simultaneously, what happens? This person is liked by this person. Okay? Is that clear or not?
Yeah.
And the other way around. So if this happens, this also happens at the same time. And if this happens, this also happens. So it means that they are equivalent statements. If you want to say that they are not equivalent, you need to give me an idea that this happens, but this is not happening. Is that clear? So if X likes Y, at the same time, Y is liked by X. So when you say someone likes someone, X likes Y, at the same time, Y is liked by X. So these two sentences are equivalent. So this is the idea that you don't need to be worried about how you juxtapose these two existential quantifiers. So it means that you are allowed to commute them, and the meaning of the sentence will not change. Yeah, is that understandable? Okay, so these two sentences are equivalent. By the way, let me try to give you some diagrams. So I will use this diagram. Assume that this universe of discourse is containing three people, A, B, C. Let me make it D. Okay. So we have four people in the set of in this universe of discourse. And then let me, instead of writing, let me do some diagrams for you. I take this X, person Y, and I draw an arrow from X to Y. Let me put the arrow here, a vector from X to Y, and I read this as X likes Y, or Y is liked by X. Assume that that's your diagram. Okay, so here, let me write A, B, C, D. And then let me write A, B, C, D here. If I draw an arrow from here to here, what does it mean? Yes? A is a narcissist. Yes, what? A likes himself or herself. Okay, but assume that you want to make this a false statement. Can you draw a diagram for me there so that this becomes a false statement? Yes? I don't have to draw it. So it means, yeah, this is the only one. Yeah. If you just leave it blank, it means if this is the case, it means that no one likes anybody here. So it means that this becomes false. Okay? So if I want to draw a diagram that this becomes false, this is the diagram. But assume that I just connect this one to that one and leave it. Do you think that this statement is true or false here now?
True.
It's true, yes, because someone likes someone. That is A that likes B. Or B is simultaneously liked by A. Yes? So that's a diagram that makes this right. Is this the only diagram that makes it right? No, we can have a lot of other arrows, yes? As far as I have one arrow from here to here, because my goal is someone is liking someone, I need only one arrow. Is that right? So this is this is probably the minimal way of drawing the diagram so that make that one true. Okay, just one arrow is enough. Is that clear? But this is also the same. Do you agree? This tells you that someone is liked by someone. Here, if I want to read it from this point of view, I say A likes B. That someone who is liking is A. That person who is being liked is B. Okay, and the other way around. If I want to see it from this point of view, that is B, that is liked by A. So these two sentences are the same. So let us try to translate this one and then try to draw a diagram to understand this better. Okay, so let me clean this. Okay, so what is this one? And so this is probably the ideal society for humans, yes. Everyone likes everyone, yes. This is the meaning. So everyone likes everyone. Is that clear? But if you want to read it properly, how do you read this one? Yes?
Everyone is liked by everyone.
By everyone, which is exactly the same meaning, yes? Everyone likes everyone, or everyone is being liked by everyone. Yes, so that's also something. I don't write it because you understand what's going on. So, by the way, do you think that they are the same or not? They are the same. So the problem arises here. You need to be careful here. Okay, so now think a little bit about this and try to read it. So for all x, there exists a y, so that L x y. For all x, there is a y, so that x likes y. And this is the other way around. Yes?
Can I say what relationship they have?
No, not the relationship. Just read this in English sentence. How do you read it? Yes?
Everyone likes someone.
Everyone likes someone. Yes. Everyone likes someone. Thank you. So number 5, everyone likes someone. This is already happening in our society, yes? Because everyone have someone to like.
If you're a sociopath.
Okay, yeah, might be. That is the counterexample for this. But assuming that this is not the case, do not look at the extremes. This is probably already there. You're trying to reach here, yes?
Yeah, if our universe of discourse is a society without sociopaths, then.
Yeah, that's correct. Yeah, that's also, yeah, that's 100% correct. But I don't know even that is true for sociopaths. Have you seen a documentary that the professor was actually investigating about sociopath? And then they were looking at this brain scan. So they realized by looking at the brain scan, they can actually say that this person is psychopath. And then the assistant of the laboratory or something brought some pictures for him. And he said that this is definitely a psychopath. And then he realized that this is his whole brain. And then he realized that might be there is another theory. If you actually grow up in a society, even though you are still psychopath, but those genes are not turned on, or probably something. That's a nice documentary. Okay, So, and that person was married and has children and loved them. So when in that case, the psychopath can also love at least one person. Yes. I don't know. That's a different story. But if you want to be on the safe side, you can just exclude them from the universe of this case. So everyone likes someone. But this one, what does it mean? Yes?
There is someone who is liked by everybody.
Yes. And that is more or less a hero, yes? If you have a hero, then probably that guy is being liked by everyone. And you see that they are not the same, yes? Because there is no necessity, because if there is someone that I like him or her, there is no guarantee that there is a hero out there that everyone likes that person. And then you see that they are not equivalent, yes? So this tells you that, yes, for every person, there is a person being liked by that person. But this means that there is a person, one single entity, a person, which is liked by everyone. And then they are not the same. Yes? But if one of them happens, the other one automatically happens, but not the other way around, because we can see that they are not equivalent. So let me at least write this. They are not equivalent. So this means everyone likes someone. Let me translate number 6. What was number 6? There is a person. There is a person that is liked by everyone. And then I hope that you feel that they are not equivalent. But what I am claiming is that one of them definitely implies the other, but not the other way around. Okay, so if you go back to the diagram, so let me draw a diagram for everyone likes someone. Okay, so for example, let me take this one. Might be this is not a good idea. Let me draw some diagram like this. Everyone likes someone. So do you think this diagram makes the first one true or false? Everyone likes someone. True. This is true, yes? Because every person that you see is liking someone, yes? But is there a person being liked by everyone? No. This person, I don't know, nobody likes this. But anyway, this person is being liked only by this one, but not with everyone. If I want to have a person which is liked by everyone, it means that that person should receive all the arrows. At least there might be different arrows, but at least one person should receive 1, 2, 3, 4 arrows. In that case, the other one is also true. Okay, now let me see here. This statement is false. This statement is true. Yes. But now can we draw a diagram that this is also true? Let me draw a diagram here that this last one is true. So I have A, B, C, D, A, B, C, D. Okay, which one do you prefer to give the role of the Godfather to that? So yeah, let us take A. Okay, so then we say that everyone likes that. Yes, and then of course we can have more arrows, of course. Yeah. So let me draw this one. Yeah, that's enough. Yeah, that arrow makes that sentence right. But do you think for the second diagram, this one is also true or not?
Yes.
That's also true. And I think if you think a little bit more, you can see that there is no way to draw a diagram that this is true, this is false. Yes? It's not possible. You can think a little bit about that. You cannot draw any diagram that number 6 is true, but number 5 is false. So what I'm trying to say is that these are equivalent, but the last one, number 6, implies number 5. So this is, so you need to know. This is the only one that you have to be careful about. It's not it's not double-sided arrow. It only works in one direction, and the direction goes from this to that, not the other way around. Because how we can feel it? Because this tells you that there is a person being liked by everyone. Okay? And then I am claiming here that everyone likes someone. That someone can be taken that person. Yes? In the worst case scenario. Is that understandable? Or confusing?
Understandable.
Yeah, I think it's understandable. This tells you that there is one particular person that everyone likes that person. Okay? This tells you that if you choose one person, you can find someone which is liked by this person. If this happens, for everyone, you can take that representative. That godfather also played the role of this wife for this sentence. You understand that? Okay, so this only goes in one direction, but not the other way around. Is that clear? Okay, so what I wanted to finalize, I think this is a very good package of mathematical logic, and this is a good point to start about mathematical logic. If you have any questions, please let me know. Otherwise, there were 3 geometry problems left from, I don't know, 2 sessions back or 3 sessions back. I want to solve those for you, and then might be we can decide about the time for the exam. Okay, let me also give you let it go to the world of mathematics. There is also another example in the book that's also nice, but this is a mathematical example. I want you to evaluate it for me. True or false? So example, and let me do this and then finish. Example, true or false? So the statement, so the universe of this course is real, the set of real numbers. The universe of this course is the set of real numbers. R. So assuming that this is the universe of this course, tell me, is it true or false to say for all x, for all y, x plus y is equal to 0? True or false?
False.
It's clear, because it tells you that it doesn't matter which number x you choose or which number y you choose, x plus y is equal to 0. So that's a false statement. Why? If somebody insists y, you should say that, okay, 2 is a real number, 5 is a real number, I add them, it becomes 7, 7 is not equal to 0, that's a counterexample. So in principle, if you want to refute something, you need to provide a counterexample. That's a have to. So that's false. Let me ask you this. For all x, for all y, this I'm adding to this example of the book. What do you think about this? Is this true or false? If you jump into it, might be you say that this is true. Yes, because you think, I hope that you are not thinking that this is the negation of that one. Yes, this was not in the book, so I'm just adding it myself. Do you think this is true or false?
False. False.
This is also false. But I hope that this is not strange for you, yes? Because these two are not the negation of each other, yes? If these two statements are negation, this cannot happen that one of them is false, the other one is also false. Yes? Because if I have P and not P, then if this is false, this is true. If this is true, this is false. That's okay. But here, both of them are actually false. Okay? Might be you are thinking that this is the negation of this one, but you know that. That's not the negation. Can you tell me what's the negation of this one? Yes?
There exists an x and there exists a y such that x plus y is equal to 0.
Is not equal to 0. Yes? So the negation, so now tell me, what is this one? False or true? This has to be true because it's itself, the statement itself was false, so its negation has to be true. Okay? This tells you that there is an x, there is a real number x, there is a real number y, so that when I add them, it is not equal to 0. Yes, 2 and 3, I add them, it's not equal to 0. That's true. Is that understandable? Okay. So, yeah, don't be in a hurry. So just by looking that this part is the negation of this part and saying that this is false, I conclude that this is true. No, because these two statements as a whole are not negation of one another. Okay. What do you think about this? For all x, for all x, there exists a y such that x plus y is equal to 0. In mathematics, we have a lot of these kinds of sentences. We need to understand what's the meaning. So what do you think? Is it true or false? This way of reading.
That's true.
It is true. Yes, for all x, there is a y so that x plus y is equal to 0. It is true. First of all, I want you to feel that this is true. And when you want to say something is true, you have to have a proof for that. What is the proof for this? You need to understand how to prove this, because this tells you that for all x, so you take a representative from the set of real numbers, you call it x. For that particular x, you are claiming that there is a y, so that if I add it to that representative x, the answer becomes 0. So there is only one way to prove this. You need to propose your candidate so that this will work. If I have x, what is the candidate for that x? Yes?
Minus x.
Minus x. Yes? That's clear. So yes. So this is true. But what do you think about this? There exists a y for all x. X plus y is equal to 0.
Yes. No.
Is this true or false? I want to give you time so that you can digest it. You need to get used to reading these quantifiers.
Very false.
It's false. It's claiming that there is a godfather, yes? There is a number, so that whatever you choose and add to that number, the answer becomes 0. It's clearly false. Yes? Yes?
But if we swap the plus for a multiplication, because I thought we didn't done, then it's true.
I don't know what is this moment here. Okay, I don't know why. Okay. May you repeat it, please?
If you swap the plus for a multiplication sign, then it's true. So
let us check. There exists an y for all x. X times y is equal to 0. Yes, you're right. And what is that y that works for everything? 0. Yes, so now you understand how to read these sentences. And that was my goal, actually, because the logic is very, very complicated, actually. Working in logic is very hard because we don't have anything before that. Yes, everything is based on the logic. And then how we prove theorems in logic, it's a whole complicated story. Okay, so that's also good. But now let me go back to the problems which was left from the previous one. I don't know how many of you have thought about that problem, or you have totally forgotten. But let us try. We have a little bit of time, half an hour. So there are 3 problems left. And I want to solve those problems for you. And if you can help me, that's much better. So if you remember, there was, let me just draw the picture for that. I have given you a triangle, CAB. This is a triangle, a scaling triangle. There is nothing particular about this triangle. Scaling means just this triangle without having any particular property. And we know something. Let me read it myself. I don't remember. So AF is the bisector of CAD. So there is a line given here. So there is a line here. They haven't mentioned anything about this. This is not a midpoint, just any point. And then I connect A to that. And there's also another one here. we call it E in the picture. And then here, oh, I have the ruler, I can use that here. And then what we do, according to the problem, you see there is an angle. This angle is mentioned CAD. CAD. I draw the bisector of this partial angle. Okay, so let me make it good. So let me bring this. So of course I cannot draw it exactly, but bisector would be somewhere around here, I would say. So we have this bisector of that particular angle here. And then we do the bisector of this partial angle. Okay, so the bisector of this partial angle somewhere around this line, so that they intersect each other at this point. So let me just get rid of these extra parts. It is mentioned to be F. So let me give you, do you agree that if I call this alpha, not to forget, that's also alpha. And then if I call, for example, this beta, this is always usually helpful to write the information on the picture so that you can connect to the whole problem by looking at it. And now we want to prove that this angle here is the average between this angle and that angle. Yes? So I want to show, am I right? Show that the angle AFB is the average between the measures of the angle AEB and BDA. ABD, where is ABD?
Babak,
Yes?
Emil wonders if you can swap pen. It's very difficult seeing the red one.
To what? Draw the pan?
Yeah.
Ah, okay.
Color.
Okay, thank you. So let me see. AFB is this, and then it is supposed to be the average between AEB. Yes, AEB, I'm right. AEB and ADB. So let me give them names. So if you don't mind, let me call this one X, for example. Let me call this one Y, and let me call this one Z. My goal is to show that X is equal to Y plus Z divided by 2, the average between these. That's the goal. I think, Luba, you sent me the solution, yes?
Yeah.
Was it this problem?
I think so, yeah.
Okay. So I don't know how many of you have thought about that problem. Could you solve it? Okay, anyone else? Yeah, please think about these problems. Because there is no way, if you don't think, of course, this is not that hard. If I write the solution for you, definitely you will understand that. But the point is that you need to practice to be able to generate the solution yourself, okay? Now, do you have any idea how to start with? I want to find a relation. Okay, because I want to solve everything. Let me start myself. Hopefully I can do it. What I see is that, first of all, let me write something, then I will ask you if that's true or false. I want to write that Y is equal to angle C plus 2 beta. Do you agree? So Y is this angle. I'm claiming that this angle is equal to this angle plus 2 beta, which is this. Let me draw this outside for you. So you have a triangle. This is B, this is C, this is E, and this is your Y. Yes, this is the exterior angle. So this is, you need to train your eyes. This is the exterior angle, so you had it in Math 1C. Any exterior angle is the sum of these two non-adjacent internal angles. Yes? So if I write this, you agree with me. Yes, and I can write something similar for z. What is that one? Can you tell me now?
Z equals the angle C plus 2 alpha.
2 alpha. Agree? But now in this triangle. Yes, so this becomes c plus 2 alpha. Okay. And now I have an eye on what I want to prove. Okay, I see that in the one what I want to prove, I have y plus z. So it motivates me somehow to add them. A y plus z. Yes, it becomes c plus c, which is 2c. It becomes 2 alpha plus 2 beta. This is also not good. No. Is that understandable? But then I want to have y plus c divided by 2. So this also motivates me to divide everything by 2. Let us see how it goes. So I divide this by 2, so it becomes y plus c divided by 2. Then it becomes c plus alpha plus beta. This is something that I get. Let me read this one as well. Okay, but then I have to convince myself, if this is going to be true, I have to convince myself that this one is x. C plus alpha plus beta is supposed to be x. How can I show that part? So C is this one. Alpha is one part of this, and beta is one part of that. How should I convince myself? This is not that easy. I mean, it's very easy, but you need to think smart. So how should I convince myself that the sum of these three angles is exactly equal to this angle x? So do you see any triangle in which somehow these three angles can be involved? Not really, yes? Because this angle alpha is somehow related to this. It's also good. C and alpha are related somehow here. And then C and 2 beta are also related in this triangle. But do you think I can do something in the bigger triangle? Yes or no? If I ask you write something here, what do you say? What is this angle? Can you tell me? If I want to write something, insist to write something here, what do you write? Yes?
2 alpha. A minus.
No, 2 alpha is this one. There is no guarantee that this is the same size. For example, you see that this is a little bit smaller than this one. I cannot rely on that unless you have a good reason for that. You need to tell me. But this is not mentioned to be the bisector. If that's the bisector, you are right. Yes?
90 minus. No.
Not 90. A minus 2 alpha. Yes? Instead of this one, I can write the whole angle alpha minus A minus 2 alpha. Agree? And for the same reason, what can I write here? The whole angle B minus 2 beta. Agree? But now, look at this triangle, the red one, AFB. What can I write? I can write the angle X. Let me not write this. Plus, this angle is how much from here to here? I am looking at this triangle. X plus A minus 1 alpha, not 2 alpha. Yes? And then the next one is B minus 1 beta. Is how much? 108. And let me move everything to the right-hand side. So X becomes 180 minus A minus B plus alpha plus beta. But can you tell me what is this? Yes? It's C. Yes? Because it is in, now I look in the bigger triangle. If I ask you what is the angle, the whole angle A plus the whole angle B plus the whole angle C in this big triangle, you immediately realize this is 180. Yes? So this means that 180 minus A minus B is just C. So this means this is C. I'm not saying that this is the only way. I just started somewhere, so I hope that I could finish it. And it is finalized now. So I was able to show that x is equal to this. This is relation number 2. This is relation number 1. If I compare these two relations, the left-hand side is equal to this. This one itself is equal to x. So from number 1 and number 2, I can conclude that x is equal to y plus z divided by 2. Again, I emphasize, I'm not saying that this is the only way. Might be you can cook up another way to do that. But I was thinking that, okay, let us think logically to see what is going on. You see, I was able somehow to realize this connection. Then I wrote this one. Then I asked myself, is it possible now to concentrate to prove this one is equal to x? It might happen that after all these efforts, I cannot solve. Then I have to go back and throw it away and start all over again. But this was work. Is that clear? Okay. Now let us go to the next problem. Hopefully I can solve that for you today. Any questions? This one sounds a little bit more interesting. So what we have, let me read it again. So let me draw the picture for you here and read it. Okay, I cannot draw it. I have to read to see what is the connection. Okay, this is not, this is B, this is C. Okay, in the following figure, the interior bisector of B and the exterior bisector of C of this triangle meet at point D. So it means that if I draw the internal bisector of angle B, this is the internal bisector. So I am drawing a line which bisects the angle into two equal pieces. And then the exterior bisector of angle C. What is the meaning of exterior bisector of angle C? This is angle C. The exterior angle is this one. So I have to bisect this one now. That is the meaning of exterior bisector of angle C. So I have to do... Okay, so if you don't mind, let me write my information. So assume that this is alpha, this is also the same alpha. If this is beta, this is the same beta. This is what I understand. But this is a very bad picture now because this will go very up there. So if you don't mind, let me cheat a little bit to make it a little bit closer to that line. Yeah, this one I have done with GeoGebra, so this is exact. But here, let me just cheat a little bit. So assume that these angles are the same, even though they don't look the same. Okay? And then from here, I draw a... So this point is called D. So let me read it again for you. In the following figure, the interior bisector of angle B and the exterior bisector of angle C of this triangle meet at D. The line segment DM is parallel to the side CB. So it means that I draw a line parallel here. I draw this line parallel to this side. So this is, on the picture, it is DM, and this is L. That was a little bit unfortunate. This is not very nice picture. Okay. If the measures of the legs LC and MB of the trapezoid CLMB, CLMB is a trapezoid, yes? It's a quadrilateral, and this line is parallel to this line. That's a trapezoid. If the legs are X and Y respectively, so the length of LC is given to be X unit of length. LC is X, MB is Y. You are supposed to calculate LM in terms of X and Y. Okay, at least the question is clear. So I draw this bisector, they meet at a point. From that point, I draw this line parallel to BC. Then I am saying that assume that someone gives LC to me to be X units, someone gives MB to me to be Y units. Now I am asking you calculate this little length here. We want to calculate LM in terms of X and Y. So we want to find a formula so that when somebody gives me X and Y, I put the values in that formula and I immediately calculate the length of LM. That's the meaning. So do you have any idea here? Yes, did you solve it before?
No.
Okay, so what's the idea?
I think we need the interior side of C,
Mhm.
setting it to be 180 minus 2b, or 2 beta.
Yes.
That's just the first that comes to mind.
Okay, so that comes to mind, but then what? Yeah, that's hard. Some geometry problems are fun and hard. It's not clear what to do, actually. Let me think a little bit myself.
Can we not calculate?
So it's a very good picture because it is not to scale at all. And then you need to discover the logic behind that. So what I am claiming, and I want you to see that for me, to prove it for me. If I haven't done any mistakes, I would say that triangle DMB is an isosceles triangle. Yeah, it means that two sides are equal. It's not clear from this picture of each two sides, but let us rely on our logic. At least you have the good picture here. You know, I can see, hopefully, DM is equal to MB. It's very bad picture. DM is supposed to be equal to MB. But you tell me why. Why do you think? So I hope that this is not misleading. If you have access to the picture that I have drawn in the lecture notes, that's good. So why do you think that this one should be equal to that one? Well, assume that I am claiming this and you want to think about this. How do you think about the problem immediately? What is the first thing comes to your mind? Yes?
That the angle MD and B should be equal to alpha.
Yes. And it is. It is a Math 1C problem. Why this angle is alpha? Remember, always this Z will help us. Yeah, so if I have a Z, it doesn't matter what is the type I write Z. Of course, N is also working. So these two angles are always equal. If I have two parallel lines and one transversal, they are equal. So this is why I'm saying you need to train your eyes for catching the points, yes? But of course, I'm completely sure everybody knows about that theorem, yes? So now you are saying that these two lines, this DM, and this longer CB are parallel, according to the assumption in the problem, and DM is connecting this point, this one to this one. You see, you have this Z. Yes, but what does it mean? It means that this angle is equal to that angle. But this angle is alpha, unfortunately, because this is a bisector, that's also alpha, yes? So I realized that this angle here is equal to this angle here, but this angle here is alpha, so this angle is also alpha. Now, if you look at this bigger triangle, I have two angles equal to alpha, so that is an isosceles triangle. Is that correct? So this means that I just don't write them because we don't have time. So it means that DM is equal to MB. And MB I don't have to be worried about because MB is Y. Yes? So this means that DM is Y. Now we have a little bit of time. I want to wait for you, but I think the idea now becomes clear what to do. Yes?
We can the same way say that the angle between DLC is beta.
DLC here. So you want to say that this is beta. Yes?
Yes.
Agree? But now this is, what is the Z now here? Yeah, this is your Z. Yes? In this form, this is your Z. So you have this Z here. Oops. You have this kind of Z, so it means that these two angles are the same. Agree? Do you understand that? This is Z. So this means that this angle, no, this doesn't work, does it? This tells me that this angle is beta.
Can't you prove that the angle?
Yes? This, at least this tells you that this is beta. Okay, but you're right, sorry. This angle is beta. This is a very bad picture, even myself are confused, yes? So here, do you agree that this angle is beta?
Yes.
Because these two lines are parallel, this is the transversal, so this is your Z. If this angle is beta, this angle has to be beta. Yes? Exactly, thank you. I confused myself. So this angle is beta, is a really awful picture, but that's also beta. So then what does it mean? Which one is equal to which one? Yes? Which one is equal to which one? The one which is opposite to B, LC, is equal to one which is opposite to this beta, which is DL. This is the mean, yes? So this means that, yes, so this means that DL is also equal to LC. Yes? But what is LC? LC is given to be X. So this is X. Actually, this is finished. It's much. I was looking for a more complicated relation, but the relation is very simple. I want to find LM. What is LM? LM is the longer line segment DM minus this smaller one LD or DL. Do you agree with me? This is LM. This part that I am interested in is the bigger one minus this smaller one. But the bigger one DM is Y, DL is X. So it was much simpler. I was just trying to look for a more complicated relation. If you just calculate the difference, it becomes LM. So I think it's better to go home and see the correct picture. So I have the correct picture. So somehow it is guiding you somehow. This is not, usually in exams, they say that this picture is not to scale. So it means that you really need to use your logic. You see, even I was confused when you say that they are the same. I thought that this is one, but that was correct. Thank you.
Is there a standardized notation for parallel lines?
Parallel, yes. When you say L1 is parallel to, and in LaTeX it's also called parallel.
No, I mean graphically speaking.
What?
Graphically speaking, in a two-line.
Yes, usually they put one arrow here, for example, and one arrow here.
Yes.
And if they put, for example, two arrows in another one, so you can say that, okay, I have these lines and these lines. So I can say this is parallel to this one, this is parallel to this one. Something like this. Yeah. Okay, I think we have a little bit of time. At least we can start the next one. The next one I remember exactly because I was excited when I was a teenager and solved that problem. So if you have a triangle, any triangle, so you have A, B, C, a scaling triangle. And then you take any point interior to your triangle. So let us say, if you want, I can read the... No, okay, there is no point in it. Okay, just take a point here, any point inside your triangle. And draw a perpendicular line from that point to this and call it L sub A. Why? Because this, in geometry, the length of this side is usually denoted by little a. I would say this is L sub L, the line drawn perpendicular. That's mentioned in the problem, by the way. I'm not justifying. This is the notation used in the problem itself. And I do the same thing for this side. And then I will make it LB, L sub B. The length is L sub A. This length is L sub B. And I do another one here, the same similar thing. L sub C. How many heights do I have for a triangle? These are not heights, yes? The height is the line that draws from, so example, this is a height coming from there, perpendicular to this. This one is called H of A, the height perpendicular to side A. And we have two more. Okay, I don't want to draw those which are getting complicated. We want to show that if I divide this length by the length of the corresponding height, and I do the same for other ones, and I get three fractions, if I add them, it becomes 1. Exactly, not approximately. So we want to show that if I divide this length by this length, which is that height, if you want, I can draw the other ones, but it becomes complicated, and you don't need them actually. So this one is HB, and the other one exactly passes through this. This is a theorem in Euclidean geometry. All of them pass through the same point, but you don't need to know that. That's not important here. So this is HC. So it seems quite complicated, yes? I have this length divided by this length is a fraction. I do the same thing with this length and this corresponding height. I get another fraction. I do the same thing for the last one. I have three fractions. I want to show that exactly, if I add them together, it becomes exactly 1. Okay, at least you can think about this until the next session. Okay, I will solve that one, and then you can start working on exam or whatever you like, okay? But we need to know when do you want to have the exam, the first exam. Because the next time I will not teach the logic anymore. I want to switch gears to another topic. I don't know. Do you prefer to have it very abstract one like logic, or you want to come back to the earth? Yes?
Abstract one is fine, but
Yes, abstract one is also fine, but abstract one is only for those people who want to study theoretical physics, computer science, or mathematics. But we can also work linear algebra, that we have a broader idea. So it doesn't matter which technical university you go, you have calculus and linear algebra. So it might be, and then in Swedish system, there is no track of matrices at all. So it might be one idea was to teach matrices and linear algebra. Which is also a very important topic. Yes?
I mean, I think it's a nice sort of counterbalance to physics, because we have some of us, I think most of us in this group have physics too. And that is like very on the ground, like raw. And then it's nice to take a break and relax and like very abstract.
Okay. If you want to do very abstract stuff,
that's my argument.
let me think. Okay, let me think if I find a way out of it. Okay. No questions? Yeah. So please think about it, and then I will ask you when do you want to have this exam. It would be very good if you have it before break. But if not, we can postpone it for after the break. That's up to you. Okay. Thank you very much. Bye-bye.